Good morning, ladies and gentlemen, and my greatest apology for the delay because of the traffic. I think this is one thing the architect and the engineers haven't figured out in Bangkok how to resolve it yet, but we will do in the future. I have been asked to talk about innovation in structural design, integration with the architect today. How do we design the approach? My understanding is everyone here is an engineer who has great knowledge of engineering know-how. But I think the way we work nowadays in A49, we've taken a different approach in the past 5 years where we try to integrate engineering process and thinking from day one with the designers, as opposed to design something and throw it to the engineers to work out the structure. So I think when the approach is different, it leads to the new outcome and the new design approach also, which have proven to become very efficient and very structurally challenging. But first of all, let me briefly introduce you to our organization. A49 is an architect's firm, has been established for 34 years now. And we are located in Sukhumvit 26, not far from here. We comprises of 650 people in the group structured company, with 11 companies in total. A49, the architectural firm, is the mother company. And within that, we also have AE49, Architectural Engineering, which is under leadership of Kun Sayan Pulitgram, our managing director of the structural department, who looks after the engineering company. So within the group structure, as I said to you, we try to work as a fully integrated firm, as opposed to work individually and then pass the scope to the next party. So we normally discuss from day one how do we want to approach and tackle the design together, from the designer vision, from the engineering vision, from the landscape, from the interior. So A49 becomes the full multidisciplinary practice in order to deliver a quality and good concept design to the client. So we run as the board of directors. This is Kun Maythin, the national artist who is the founder of A49, and he has retired for 4 to 5 years now. Kun Maythin founded A49 in 1986, and since then I think A49 has become one of the leading practices in the country. And as of today, we are also stepping into international platform to undertake international projects, either in Indonesia, in Malaysia, China, and a few other countries within the Southeast Asia region. And in the past 10 years, it has been under the leadership of Kun Prapakon, which gentleman on the left, he is our managing director, which he was supposed to be here, but great apology on his behalf that he has some urgent appointment that he couldn't make it. And the rest becomes the board member who assists Kun Prapakon to operate the company. And we divide it into 3 studios, which I'll explain later. And that, for example, myself and Kun Somkiat look after studio number 3, and Kun Pichai and Kun Nitis look after studio number 2, Kun Suwat and Kun Krisida look after studio number 1. So within A49, we have approximately 160 people. Okay, and that's the organization chart. As you can see, that's how we divide the studios. Studio 4, that means our branch office in Khon Kaen. Apart from Khon Kaen, we also have branch offices in Phuket and in Chiang Mai. So we try to cover throughout the country, all the regions of Thailand. And within that, we also have support department, and on the right-hand side is our affiliated firm. For example, AE49 is one of them. So therefore, when we take the scope of works, we work closely with our group companies. And that's the profile of AE49, the structural company. And AE49, as I mentioned earlier, is under the leadership of Kunsayan, the managing director of AE49. So I think Kunsayan has been very instrumental in helping us, the architects, to design some of the challenging projects. So that these are the typical profile. I think this is another landmark building on the outskirts under Mahidol University, which I think will come into the slides at a later stage. Okay. Right. So let me start on the topic, the architectural innovation and challenges in tall building. I think when I received this topic, the agenda, so we have to come up with how do we define this topic and how do we actually talk about and discuss the way of the working approach. As I said to you, we prefer to work together as a fully integrated design process from day one, as opposed to the designer just come up with a vision and pass it on to the engineers. So we took one example of this building. It's a condominium project along Rama 3 near the river. It's called Starview. I think many of you who live in Bangkok may have seen that on the way outbound on the suspension bridge opposite the Kasikorn Bank building. This is one of the early days of fully integrated design approach and thought process between the designer and the engineers. The reason being is, that's the location, and that's the initial sketch. I think the reason I took this project as an example to discuss today is we as architects, we actually don't have much great knowledge in terms of the engineering calculation or anything, because we more like dreamers. But the bottom line is we need to understand the structural principle, how it works, and then collaborate with the engineers together to get the result. So if you look at the sketch, the bottom right sketch here, that's when we came up with the initial planning of the building. Because the brief was we needed to have 2 high-rises, 50-story and 45, plus minus. And the way we design tall buildings, normally you would come up with, the conventional process would be center core with perimeters around. But we actually had different thinking. So if we could actually distribute the cores, so therefore you have one center core, but on a smaller scale, not the same size as a typical center core, but you actually separate all this black hatch area. So this becomes shear walls of the lifts, distribute on the floor plan. So therefore, you begin to distribute the strength, the stiffness along the floor plate. So that within that concept, all the column sizes along the perimeter are now smaller than usual, because you have the rigidity of the core spread out on the footprint as opposed to one center core. And let me just take you to the typical video, just in case some of you may not have seen the project. But I'll come back to the design process later. That's the suspension bridge. The Kasikorn building is along here on the opposite side. This is the Bangkok side. So basically, it's a tower A and B with the structural bridge, steel bridge, linked between the 2 towers as the common facility on the top, on the floor 45. This stands at around 80 meters. This is the smaller tower stands at around 140. It's not a super tall building, but it's still considered a tall building. This is one of the key challenges where we had to link, as a concept, we had to link the common facility together between the two towers. And I think there was so many exercise and thought process with Kun Sayan, with the engineers, to come up with how do we tackle the lateral movement. Whether we stiffen the both towers, or do we allow them to move independently? And I think the conclusion in the end was that the engineer designed the two towers with us to make it as one, so all the movement becomes one. So therefore, this bridge link is very stiff and becomes the connecting joint between the two towers. So all the movement will move together. This is to avoid the cracks and any big movement on the bridge. Okay. And this is the tip on the ground floor plan. So that's Tower A and that's Tower B, that's parking podium. And another thing that when we designed with the engineers from day one is we try to avoid tower imposing on top of the podium also, because you are normally end up with big transfer. So therefore, if you can separate the parking footprint out, you get very standalone and free of the structure, come all the way down to the ground without any transfer. And it has also proven that the efficiency of the parking is actually better because you have no interference of other structure in between. And this is a typical floor through to these other facilities. Typical floor, if you look at that, if you remember the sketch on a few slides earlier, if you take one typical floor, that's how the core arrangement is. So when the concept started with trying to distribute the cores, that's the red zone shows the strength. How do you distribute the load? And the columns become secondary. So with this footprint, you actually have, basically you have 1, 2, 3, 4, 5 primary cores with the columns to support. So I think the way of thinking is different, because in conventional way, we would have the center core packed in the center with the columns along the perimeter. And most of the time, on my experience, when you have that system, it is very good because you have center core, but the columns along the perimeter tends to be very, very big for a 50-story tower. So therefore, I think this helps to a degree. But when we decided to take the engineering approach as the design concept, it also led to the new way of architectural design. So we came up with private lift concept, where we use that lift core as the structure, and then we deliver both sides to the units. So all the units on this development has private lift concept access to the foyer, to the room. This also gives you the resistance to the horizontal lateral load, because you begin to have the core on 4 directions to support. And this is on the facility floor, where you link the two towers with this long bridge of 80 meters swimming pool long, and this is made by steel structure, prefab, and lifted up piece by piece. Okay. This is the facility floor, and that's the section. As you can see, it is linked on floor 45, and this is to link the two towers together to make sure that all the movement is considered as one. Okay. And I have a little video clip to show you on the steel structure. And the steel structure itself actually has, this is 4 meters deep, and it has catwalk access inside for maintenance and sprinklers for safety. That's the gap below. That's the gap of the steel structure that we worked it out with all the services and M&E rooms and below. And these are drop-off images. This project is nothing in terms of the luxury. It's not considered a high-end. It's only grade B. But it's how you actually tackle the design approach. How do you create value and a design concept from it? And that's the bridge I'm talking about. So this is a vision. This is the view taken from Rama 3, as you can see, the 2 towers with the bridge ring on the top. This is a picture taken during the construction. That's the steel pieces lift up to construct the bridge. The construction cost of the bridge structure itself came up to around 150 million just for the bridge. And that's also another view from Tower B looking to the swimming pool edge, and that's the in-situ cast concrete on top of the steel works. Okay, and that's and then the finishes cladding, the aluminum cladding to clad that. I think at the beginning we also thought if we could express the structural elements, but somehow the local market doesn't seem to perceive structural element as luxury in Thailand. So we end up having to close it off. But this video clip is very interesting. If you look at it. We took it from the contractor, and they filmed it with, I think, 300 times speed of normal. Every 1 hour it lifts something like 30 centimeters, 300 millimeters. So therefore, within a day, you can't even lift it up to the top yet because of the weight. But the good thing is the whole piece is prefab from outside and get delivered on site and lifted up piece by piece. So in total, there were 5 pieces together and assembled on the top. The contractor, I have to say, give applause to Italian Thai. I think they were very good at this. But they had to collaborate with a French contracting company also on this particular bridge structure. And it was quite challenging because we also went and witnessed the lifting process. And the most amazing thing is when they lifted up, the tolerance was less than 25 millimeters of alignment. And what we were informed by Italian Thai is they use the same technology as how they build a long suspension bridge on this construction method. And these are the images of the completed project, which has been completed for almost a year now. And in addition to the collaboration with engineers from day one, we also did this building, we did the wind tunnel test in Australia in order to make sure that the structure, the pedestrian wind load can be withstand and resisted, and how we designed together with the engineers, and it was proven through the wind tunnel process that the structural design is almost 8 million baht more efficient than without wind tunnel design, because from the wind tunnel report, Kun Sayan was able to redesign and value engineer the structural design a lot more efficient. Well, one thing we kind of it was our first learning curve also. We also forgot. We feel the water, but the building is so high, so the water just gets swept away by the wind. So you never get the water right to the edge in the end. The next project, we'll do some windbreaker to make sure the water maintains the same level. But I think it's still considered one of the most challenging projects that we ever commissioned to do. And I think this is something that I threw up as an agenda for discussion today. What do architects expect from engineers? I think that's the key, because from what I have worked in Thailand, the process is normally we come up with the designer come up with something, and then the engineer just come up and try to work it out, and then you talk, okay, can it be done, can it not be done, and you resolve it with technology. But I think Stadio had proven the different approach of working. If you actually work together from day one, and the engineers no longer become just an engineer, it actually becomes the architect, and the architect also becomes the engineer, you actually can achieve a better result. And this is the experience that I used to work with Burahapo in London many years ago, and I was so impressed. I was just graduated, and I remember, and I had a building to do. I came up with a design concept with some structural concept also, and I passed it on to Burahapo London. And a week later, they came back with 3 options beyond what the architect, what I designed, what I came up with. And their options came up with structural solution as well as structural aesthetic. So therefore, if I went with one approach, they came back with more options, which were structurally sound, as well as aesthetically, pleasant looking. And then we developed from their option also. So I think that's the way which I think, if this can be implemented more in the country, it would actually deliver very, very challenging projects. Because if you look at big names like Foster, Calatrava, these people, they have great understanding of structure as the basic knowledge. That's how they come up with the new architectural language and design, and more efficient. And they are one of the leading people who actually bring structure to beauty. Structure no longer becomes something that people do not want to see. Structure becomes something that people actually want to see. So I have another project. This is the last one now. This is the Mahido, the Orchestra Symphony Hall, the first of its kind in the country. But this also, the approach on this project was also very similar to Starview. We started with the engineer from day one. It wasn't just the architect's vision and then pass it on to the engineer. So we started together. We begin to design based on the concept of human skeleton. But how do we play and design the structure of the engineer and beautify and enhance the building image and the building design? I think this is one of the early projects of A49 to prove that how we can actually collaborate together and deliver very outstanding result. But unfortunately, as I said to you, in Thailand, people do not consider beam trusses and steelworks as beauty. So we ended up having to clap over the roof because of the university as the client. They think, well, it looks more neat with the finishes. But in reality, if this building was done abroad, all the steel structure would be expressed. And I have to say, the steel structure looks amazing, the way it has been designed. And especially when Kun Sayan designed this diagonal bracing, the cross bracing actually helps to give the dynamic shape and form and pattern on the roof. Because the area of the roof is so great at the moment. And if you look on the plinth, the design of this, because it was based on the skeleton design approach, human skeleton design approach. So instead of having typical vertical column to support, and we also discussed with the engineer that if you had the vertical support only, the pressure from the trusses will be pushing sideways. So therefore, you're going to end up having to deal with the lateral movement big time. So instead of having just typical vertical support, if we change it to a Y shape to support it, so that one will take the load, the diagonal load from here, and that one to support the eaves, and then take the vertical load down. So I think this is part of the thinking process, the thought process, that when we collaborated with the engineer from day one. So the engineer actually have great input to the architects to deliver the aesthetic as well. And this is the result of what has been designed as a fully integrated approach between engineers and the architect. And this is the first building of its kind. It holds 2,000 seats in Mahidol University. And that's a Y-shaped structure, as you can see. This is concrete, by the way. And the roof is made from steel. And I think that's roughly what I have brought in today for discussion. So I hope it becomes useful to a degree.